In this video, we're going to talk very briefly about molecular orbital theory, and this differs from class to class. Some Gen Chem classes go into great detail on this, and some Gen Chem classes barely even introduce it. So depending on the level of depth that your particular class discusses this, you might go into greater depth than this, or maybe this is just sufficient for what you need for Gen Chem. For my Gen Chem class, this is about as far as we go. But like I said, different classes go different ways. Alright, so we're going to talk about sigma bonding first. This is the overlap of sp or sp orbitals, or also hybridized orbitals, which are talked about in a different video. So for instance, if we have a 1s and a 1s, and notice they're both positive, right? I forgot to put a plus sign here. A positive 1s overlap with a second positive 1s overlap gives us a constructive interaction, which is called the bonding interaction. All right, so this would be a sigma bond. It's the overlap of two 1s orbitals. The electron density is shared in between the two in a constructive way, meaning that they're both positive signs. All right, so that's constructive. Now compare that to anti-bonding configuration, where the overlap is out of phase. In other words, one is positive and one is negative. So if you can visualize one being above the axis and below the axis. If you add these two, you're going to get a node in between them, right? You're going to have a positive sign and a negative sign. And this is destructive interaction, right? This is called anti-bonding. All right, so this is the constructive interaction that would result in a sigma bond. And then we call this one sigma star because it's an anti-bond, right? Because the overlap is out of phase. In other words, they are opposite signs of each other. That's a destructive interaction, which we call anti-bonding. So that's sigma bonding and sigma star. And then here's pi bonding. Pi bonding is the overlap of p orbitals on their sides. And again, you can have two configurations. You can have the constructive and the destructive. So if they're lining up on top of each other, positive on positive, negative on negative, right? My drawing here is a little bit sad, but you get the constructive. So that would be a pi bond that results here. Electron density on top, electron density on bottom. Whereas in the pi star, or the anti-bonding, you have destructive overlap. So you've got positive, positive, negative, negative. When you add those together, you get another node. Okay, so this is the destructive molecular orbital, or the anti-bonding molecular orbital. And this guy, I forgot how to spell the word energy here. This one is higher in energy. The pi star is energy higher than just regular old pi. So again, this just is an introduction to molecular orbitals, and again, it will depend on the depth that your class covers. This is about what I would expect from my general chem students. And I hope this helps you get started.